So hello everyone, welcome to our second When JHipster Meets Companies meetup. Today I'm joined by Jason and Matt. Welcome.
Howdy.
Thank you. Yes.
So today Matt will present us JHipster and Okta, and Jason will present us JHipster and Micronaut at Object Computing Inc. But first, I wanted to bring back a few memories. So this was 5 years ago when Matt presented a conference at Devox about JHipster, and I think this is kind of one of the of the talks that put JHipster that brought JHipster to the audience and kickstarted our popularity. So thank you, Matt, for that. Do you remember it?
I remember it well.
And today, so you work for Okta, and Okta is our #1 financial contributor. And I think you have now contributed over $35,000. So thanks a lot for Okta. I mean, without them, a lot of things wouldn't be possible today. And I also introduce a bit OCI. We developed a new blueprint for JHipster, which you can access on this URL. But that was just a brief introduction. I will leave the stage to Matt. So to you, Matt.
All right. Can you see my presentation? DNA, yeah? All right. Well, I'm going to take my glasses off to reduce the glare a bit. But this presentation, just like the initial slide said, is JHipster and Okta. I found this hipster picture on Unsplash there, so I thought I'd use it. I think it was appropriate. My name is Matt Raible. I grew up in the backwoods of Montana with no electricity, no running water. I had to walk 1.5 miles to the bus stop every day. And it felt like it was uphill both ways. Nowadays, I live in Denver, Colorado with my beautiful wife, Trish, my 2 awesome kids, Abby and Jack, and I also have a middle child. His name is Hefe. I bought him off eBay in 2004 and spent 12 years restoring him from 2006 to 2018. And so he's been done for a couple years now. He's got a Porsche engine, rockin' stereo system, really fun to drive. I work for a company called Okta, just like Pierre mentioned. My dad called it Okra for the first couple of years. Now he calls it Okta. So he's still not quite there, but he's close. And like was mentioned earlier, we've contributed over $35,000 to JHipster, and I can work on JHipster whenever I want as part of my job. So it's very nice that Okta affords that luxury to me. So today I'll be talking about what the heck is OAuth and OpenID Connect, abbreviated as OIDC. We'll talk a bit about JHipster's OAuth implementation, and then I have a few quick demos. And so the reason I want to talk about OAuth and OpenID Connect is because that's what Okta does. We're an identity provider that provides APIs for you to add authentication and authorization into your application. And so a lot of OAuth is designed to solve the delegated authorization problem. How can you let a website access your data without giving it your password or your credentials? So first of all, don't do it this way. Back in the day, like 2005, 2006, when you would sign up for something like LinkedIn or Yelp, at the end of that sign up process, chances are they would prompt you for your Gmail or maybe even your AOL address, and then you would be responsible for putting that in, and they would go out and fetch your contacts and spam all your friends. Well, there was no guarantee that they didn't keep your password and try to do it again in a few months. So we wanted to basically take it so passwords weren't shared with applications, because it's just not a great idea. So it's crazy that people used to do this, but at the same time, I think there's a lot of people on the web that are still okay with it because they haven't quite been educated. So if this was my parents and they saw, put in your Gmail credentials, they might do it. So luckily, a lot of companies and apps have gotten away from it. And so have you ever seen one of these? And of course, the audience says, yeah. So this is a dialogue for logging in with Facebook. And so if you've seen a dialogue like this before, then you've used OAuth before. So delegated authorization inspired OAuth. And you can think of it as hotel key cards, but for apps. So if you have a hotel key card, you can get access to your room. But how do you get a hotel key card? Well, you have to do an authentication process at the front desk to get it. So you have to produce some sort of identity. Usually it's like a driver's license or a passport. And then after authenticating and obtaining the key card, you can access resources across the hotel. Right? So the OAuth authorization server is the lady at the front desk. Your access token is the key card. And then you can access the pool, your room, and you can't access other people's room, just your own. And so delegated authorization with OAuth 2.0 can also be thought of as I trust Gmail and I kind of trust Yelp, and I want Yelp to have access to my contacts only. So that's where you're giving that information to them. And one of the things I like to do is show the flow in a few different scenarios with some different terms associated with it. So to begin with that Yelp example, if we look at delegated authorization with OAuth 2.0 and Yelp, there'll be a button instead of you actually putting in your Gmail credentials. There'll just be a button that says connect with Google. And so then you'll be redirected to Google. You've probably seen a prompt if you have multiple Gmail accounts. And if you're not logged in, it'll log you in. And then after that, it'll redirect you to accounts.google.com. Chances are it'll display a consent screen. And on that consent screen, it'll say, do you want to allow this application to access your data? And then it'll go back to a callback that you had on Yelp. And then Yelp can use that access token to access your data. So one of the reasons that OAuth 2.0 is so confusing is because there's so many different terms. And so I like to break it down into more plain English. We're going to talk about actors, clients, authorization server, resource server, access tokens, and redirect URIs. So to begin, actors are basically a resource owner. So that's one who owns the data in the resource server. For example, I'm the resource owner of my Facebook profile. I'm the resource owner of my Google contacts. A resource server is the API which stores the data that the application wants to access. So in that case, it would be Google contacts, or my Facebook is the resource profile or the resource server in this instance. A client, this is the most overloaded term in computer science and in our industry. It's the application that wants to access your data. So it's not me, the client. It's not my browser, it's the actual application. And then the authorization server is the main engine of OAuth. So the resource owner is a role that can change with different credentials. It can be an end user, it can also be a company, it could even be a service that talks to another service. So to substitute some real world things into this diagram, Google is the authorization server and Gmail is the resource server with contacts or mail or whatever you want to get to. So there's also clients, and clients can be public and confidential. And there's a significant difference between these two in OAuth nomenclature. So confidential clients can be trusted to store a secret. So they're not running on a desktop or distributed through an app store, and they're not in a browser. People can't reverse engineer them and get the secret key. They're running in a protected area where users can't access them. So public clients are browsers, mobile apps, IoT devices. You can see from the slide here, they put smart TVs into confidential clients. I don't know if that's true because people can hack anything these days, but a server, right, or a cloud server where your JHipster app is stored. As long as all the OAuth flow is happening on the server, that's considered a confidential client. You also have to register your client with OAuth and the authorization server. And so client registration is a key component of OAuth. It's like the DMV of OAuth. You need to get a license plate for your application. And this is how your app's logo shows up in an authorization dialog. It's part of this process where you might specify it when you register your app. The interesting thing is it is just a license plate. So you don't really care too much if other people see it because it's just an identifier. It's not like a client secret, which is like your social security number, right? You don't want anyone to see that. So tokens are retrieved from endpoints on the authorization server. And the two main endpoints are the authorized endpoint. And this is what you can send a string to with a number of parameters, and it'll redirect you to a login. Or if you're already logged in on that server, it'll redirect you back to your app. The token endpoint is where you get access tokens and refresh tokens, and they're separated for different use cases. So the refresh token is always going to go to the token endpoint, and then the access token can be inspected on the authorization server as well. So access tokens can be different. They can be opaque, or they can be things like JWTs. So OAuth has two types of tokens. There's an access token and a refresh token. And access tokens are the token the client uses to talk to the resource server. They're meant to be short-lived. Think of them in hours and minutes, not days and months. The other token is a refresh token. This is much longer, days, months, years. They can be used to get new tokens. So if your access token expires, goes out and gets a new one. And refresh tokens can be revoked. Access tokens cannot. So when you're revoking an application's access in your Facebook profile or in Twitter, you're basically killing its refresh token. And so you can see that it's interesting because refresh tokens, according to OAuth, in the browser are actually not permitted. What I've noticed with Keycloak and how JHipster has it configured is you actually can get a refresh token and you can send it to Keycloak to get back an access token. But according to OAuth spec, that is not allowed. So, you know, people do it different ways. On Okta, you have to send a scope of offline access to get a refresh token. And if you do that from a browser, it'll actually error out and say this is not possible. So the OAuth spec doesn't define what a token is. It can be in whatever format you want. There's self-encoded tokens, which you can read all that. I'm not going to read it to you, but it's basically JWTs, right? JSON Web Tokens, where they have a header, a body, and a footer. And the footer is the signature, and the body is like the claims, the data, and the header is like what algorithm it should use. There's also opaque tokens. So like the last slide says at the bottom here, OAuth doesn't define the format of a token. So a token can just be a random string of characters, and that's where that introspect endpoint comes into play, because you can send that random string of characters to that endpoint and validate it. Well, with a JWT, you can also validate it locally, right? Because it does have that signature. You can get the JSON web key set to actually have the keys to inspect it and validate it locally. But one thing a colleague brought up recently is JWT is also just a random characters or a random string of characters, right? So you can send that as an opaque token to the introspect endpoint and do remote validation as well. But for performance reasons, you might not want to. So that's the whole thing. Now you know OAuth, or at least the most popular secure flow, which is known as authorization code flow. There's basically like 5 or 6 different flows, and I'm just going to walk through authorization code flow with a little more of those terms defined. So the client is Yelp.com, right? It's an application. The resource owner is the one that owns the data that they want to give that application access to. So they click the connect with Google button, goes to the authorization server, and as part of that, it actually specifies a redirect URI. So in this case, it's yelp.com/callback, or CB for short, and it sends a response type of code because that's what you want to use with authorization code flow. The authorization server is the one that has control of your credentials, and then you'll get consent just like normal. It'll go back to that redirect URI. So one of the things you have to do when you register your app is typically you have to give it an explicit full URL. So in this case, it would be, https yelp.com/callback, and it would be as part of the application registration. Companies that allow star or wildcards, it's actually against the spec. So that is not a thing that's allowed by OAuth 2, but there's servers, we use it with Keycloak, we have wildcards in, but a lot of them won't allow you to. So it comes back to that redirect URI with an authorization code, and then that app or client will exchange that authorization code for an access token. And once they have that access token, they can talk to the resource server. So you might be wondering, well, how does OpenID Connect fit into this? Well, OpenID Connect adds an ID token and a user info endpoint for getting more information about the user, and a standard set of scopes, as well as a standardized implementation just for the ID token, which is JOTs or JWTs. So OAuth 2.0 is never meant for anything related to authentication. It was just authorization. And so what happened in like the late 2010, 11 era was companies like Google and Facebook would use OAuth. They would also establish a /me endpoint that you could send that access token to and get users' information, so you know who the user is, which is identity, which is authentication, right? And so OpenID Connect basically standardized that. So instead of /me, it's /user info in most cases, and you can get the user's identity from it. So OpenID Connect doesn't exist without OAuth. It's just a thin layer on top of it. And so to look at a diagram of how that looks like with OIDC, in this case, everything pretty much looks the same, but you'll see our scope changed. We have to have OpenID in there, and then you can use profile, you can use email. There's about 10 different scopes you can have in there that'll get you back the data you're looking for. And then request consent, of course. Everything else is the same, except when you exchange that access token, you will get, or that code, you'll get an access token and an ID token, and then you can get that user's information either from the ID token, or you can call that user info endpoint and get more information about them. And so trying to understand OAuth might feel like you're trapped inside a maze of specs and trying to find your way out. And before you finally do what you actually want to do, build an application and add authorization, you're just like lost. And so OAuth 2.1 is in the works, and the main goal of it is to capture the best practices in OAuth 2.0, as well as its well-established extensions under a single name. So my colleague Aaron Parecki is on the spec committee. He wrote this blog post about what is in OAuth 2.1, and I'll just summarize it here. So PKCE, Proof Key for Code Exchange, is required for all clients using the authorization code flow. So implicit grant is omitted, and this is how a lot of browsers have done OAuth code flow. They've had the access tokens come back in the browser's URL, and that's not a great idea. So a lot of that's because when OAuth was first invented, we didn't have CORS, cross-origin resource sharing, like you had to put things in the URL. And so now you can do, back channel, XHR, as long as, CORS is enabled on the server for your client, then everything will work. The redirect URIs must be an exact string. Resource owner, which is basically username and password, is meant for older clients, but people are abusing it, so they're omitting that, because if you're using resource owner and you actually have a username and password in your app, then it's the same thing as you actually, storing credentials locally. And then a few other things that you can see there. So now moving on to JHipster's OAuth implementation. This is the base generator, and obviously any blueprints that are outside of the base generator will do things differently. But with the basic generator, which is Spring Boot and Spring Security and Spring Cloud, we leverages Spring Security's OAuth and OIDC support, which has gotten drastically better in the last few years. So the folks working on that have done a really good job, and we lean on them for their help when we have issues. If you're doing microservices and you have a gateway with Spring Cloud and you're using Zool, so this is just a normal non-reactive application, then we have an authorization header filter that will process and send the access token downstream to other servers so they can communicate. And then we also support Spring Webflux and Spring Cloud Gateway. Again, that wasn't a whole lot of work for us. It was mostly Spring Security making that possible and Spring Cloud Gateway. So those teams were a great help for us making that work. And then one of the things we had in JHipster, I think is kind of funny. When I first started working on the OAuth implementation, what I found was JHipster was actually storing the client secret in the browser. And they had that code like in the JavaScript. So I was like, whoa, this isn't going to work. And then as we started to add more front ends, I realized that if I do all the authentication on the front end and then pass the access token to the back end, well, then we have to find an OIDC client for Vue, for React, for whatever new front end is going to come on the market. And so what we decided, we made a strategic decision, largely because it's the most secure, is to make all the flow happen on the back end. So when we click sign in on a JHipster front end, it just redirects to Spring Security and it does all the work, and then it does the same old-fashioned cookie-based, session management between the server and the client. And so for the first year, people would complain that you couldn't actually log out. And so for the first year, I got away with saying that, the reason you can't log out is because if you logged into an app with Facebook and then you logged out of the app, you wouldn't want to be logged out of Facebook. And that's what people essentially were asking for. Well, push came to shove and we decided to implement it. So now there is a logout resource that returns an ID token and a redirect URI, and then the client handles sending that to the IDP, whether it's Keycloak, Okta, or someone else, and logging the actual user out. And so I think developers really like that with JHipster because they are testing different users all the time, and so they do want to be logged out of the identity provider. And then we create a Docker configuration that's got pre-configured users in Keycloak. And so you don't have to set up Keycloak. You don't have to register your apps. We've already done all that for you. And so typically, if you're doing a Java one, you will have a security configuration that looks like this. When you choose OAuth for your authentication, it sets up OAuth 2 login, which means if you hit a particular endpoint, it'll redirect you to log in, and then it'll come back and everything will work. There's also an OAuth 2 resource server set up by default, and this means that clients like Ionic and React Native can actually talk to a JHipster application and just send a JWT to authenticate in there. So you could write a whole new client that didn't use what JHipster provides. As long as you're doing the authentication there and sending the access token, then that will work with the JHipster app. And then the OAuth 2 client is actually for communicating between JHipster app and another app like server-to-server communication. And then all the configuration is stored in application.yml. So you can see it's pretty long there, right? It's deeply nested, so properties might look a little better, but still it fits on one slide, so that's pretty good. And we hard code it to Keycloak by default, and then we have whatever we've configured in Keycloak in there. And so if you want to use a different identity provider, ideally all you would have to do is create a groups claim and add it to your ID token, and then you would have the groups that JHipster expects. So that's a role underscore user and a role underscore, not group, should be admin. I'll fix that before I publish the slide. So role user and role admin, and then you register an OIDC app at your IDP, and you will have to specify a certain redirect URL that we use from Spring Security, and then you'll override the default settings with environment variables. So these are those ones you saw in that YAML file, and you specify your issuer, your client ID, and your client secret. So as long as you set all this up and then tell JHipster to use these new variables, then everything should work. And so I have a couple demos for Keycloak, for Okta CLI, and for Heroku. And what I've learned from doing these presentations virtually is when I have my laptop plugged into an HDMI and I'm in an audience, I'm in person, usually everything just goes well and goes fast. But virtually, sometimes it's hard to see the fonts and everything. And so what I'm going to do is I'm going to walk you through in slides what the demo is, and then I'll try those demos as well, and we'll see how it goes. So to do JHipster with Keycloak, you can create a blog OAuth 2 directory. You can name it whatever you want, but you do have to create a directory and execute JHipster inside there. So then you'll CD into there. And we have a new command called JDL. So it used to be import-JDL. Well, if you use the new JDL one, it'll actually go out to our JDL samples repo and grab a matching one if it matches there. So you can just type JHipster JDL blog OAuth 2. It'll go out and fetch that JDL, create your app, and then once it's done creating, you'll want to start up Keycloak, right? Because you'll need that running. And in fact, if you don't have it running, it'll fail. It'll fail to start up because it needs that identity provider there. Just like if you're doing a JWT application and the database wasn't there, like the app would fail to start. So then you start it up with Maven. This is using Maven. Of course, you could use Gradle if you wanted. And then you open up localhost 8080, click sign in. It'll go to Keycloak, log in, and you'll be good to go. So that's the first demo. The second one is with our new Okta CLI. So take is a shortcut that exists in OMyZSH for make dir and CD into it. So I love using it because it does two things in one. And then you can run that same JHipster command, and then you'll need the Okta CLI installed. So if you have Homebrew, you can easily install it using that or other package managers on other operating systems. It'll create a .okta.env file for you. You can source that, and it has those overriding Spring Security variables. Start up your app, open it, and you're at, when you click on sign in, you'll be redirected to Okta. So the cool thing about that Okta apps create, when you choose JHipster, it does all that work I talked about before. It creates that groups claim for you. It adds those users to, or adds your user to the actual groups, and it creates role user and role admin if they don't exist. So the last one is JHipster with Heroku and Okta. And this was actually done as part of the work that the OCI team did and Jason did to make Micronaut work. And so when we were originally developing this, I was like, wouldn't it be cool if you were able to deploy to Heroku and it detected that you're using OAuth 2? And if you were, then it actually created an Okta account for you and everything. And because we have a Heroku add-on for Okta, so that made it a lot easier. But yeah, now you can do the same thing and just do JHipster Heroku, and it provisions the Okta add-on and creates those groups, creates that token and all that. So that's pretty neat. Let's give it a try here. So I will mirror my screen. And then hopefully y'all can see this. So I actually went ahead and did this beforehand because it can take a while to run, and I've noticed it's a lot slower when I do it, virtually or when it's recording my screen. So you can see I just did the take blog OAuth 2, and I'm in Denver. It's about an hour ago, and I ran this, 9:30 in the morning. JHipster JDL blog OAuth 2. It goes and grabs it from this URL, and then it creates everything. And so down here, you can see it installs it all. And then I ran JH keylookup. So if I do an alias of that, you can see it's that same command I had in there earlier.
Matt, maybe you need to share your screen again.
Uh-oh.
On StreamYard. Yeah, because people cannot see your screen. No problem.
When I mirrored it, it unshared it. Okay. So now you can see it, right? So again, the commands up above, if I look at the history, you can see I did JHipster JDL blog OAuth 2, and then JH keylookup. And if we look at that alias for JH keylookup, you can see it's just starting that Docker container. If I do Docker PS, it's still running. And if I do MVN, then it'll start it up and it'll talk to, keykloak by default. And then while that's running, we can also configure it with Okta because we haven't sourced anything, so we haven't overridden those variables. So if we do Okta apps create, if you don't have an Okta account, it'll prompt you to create one. So we'll just do that, and then I'll say it's a web application, and then it's JHipster, so 1 and 3. And you'll notice this is the redirect URI you need to set whenever you're registering a JHipster app and you're using OIDC. And of course, if you're in production, then you're going to want your production domain name, /login OAuth2 code OIDC. And the reason we use OIDC instead of like Keycloak or Okta is we like to keep it generic and make it easy to switch between them. And so we'll just use that default there. And then the post logout redirect is the same. It's configuring a new OIDC application. It set up that groups claim. It added me to it, and the roles already exist, so it didn't create it. So, and it wrote it to this octa.env. So if we look at that, you can see it's just those export statements I had before. There's my client secret, don't tell anyone. So this is still using Keycloak, right? And if we logged in, then all that works. And we're an administrator, so we can see everything. And then if we were to shut that down and source octa.env and run it, now we'll be using Okta. Hopefully it detects that it doesn't need to, rebuild the front end, and everything starts up pretty quickly. Of course, there's a command I could have done to skip Webpack, but I didn't put it in there. But we're close. And while we're doing that, I'll look at my Heroku apps. I already deployed this to Heroku last night, so you wouldn't have to wade through that process. But I think it's blog, one of them. So this one right here. So we can do Heroku open. -A. So it prompts you when you do JHipster Heroku, if you're using OAuth, to actually, configure Okta, and then it does all that for you. Back here on our local one, it's running. So you can see we're logged into Keycloak. So we're going to want to do this in a incognito window because the ID token will fail if we try to log out. Now it redirects us to Okta. We can log in there, and it's just a regular user, right? It's not in the role admin group, so you don't see an admin menu. And then we have, I'm just using a free tier on Heroku. That's why it took a bit to start up. But now you can see if you click on that, it takes you to Okta login as well. Hopefully I can remember my password. Nope. But it works. I just forgot my password. So back to the presentation here. There we are. So there's a number of JHipster tutorials that I wrote on developer.okta.com/blog. There's Better, Faster, Lighter Java, Java 12, and JHipster 6. There's microservices. That's the second one. There's also mobile with Ionic or React Native. JHipster has both OAuth support for those, and those are modules that exist outside of JHipster that's maintained by John Ruddell and myself for Ionic. And then I worked with Jason on this build a secure Micronaut and Angular app with JHipster, and that was a really fun project because I'd find bugs and they'd fix it like in an hour, and then we'd move on. So that was a great collaboration there. If you go to that URL at the bottom, it shows all the JHipster related posts on our blog, and I do plan to write one on reactive microservices in the next month or two, so that'll show up under that listing as well. So if you like web security, check out our blog at, like I said, developer.okta.com. And we have YouTube, Oktadev, and Twitch, and Twitter, all at that same handle. So thanks. Keep in touch. I'll upload this presentation to SpeakerDeck as soon as this meetup is over. And a lot of the code I write these days is on Okta Developer. So thank you, and may the auth be with you.
Thank you, Matt. It was a great presentation, and thanks a lot also for all the the introduction about OOs. I mean, it's something that is really confusing for developers.
Yeah, it took me like a year to understand, even though I worked for a company that did it.
And so with this, I welcome Jason for his talk. Thank you, Matt.
Hello. So let me share my screen here. Can you hear me okay?
Yes, we can hear you.
So, and while I'm doing that, I'll say that today I learned about the take command. I tried that while Matt was talking there, and it worked beautifully. And I'm certainly going to start using that. That's pretty cool. So let's see. All right,
Okay,
you can
so
see
I've set up your screen so you can start.
Great. All right. Hello. My name is Jason Schindler. I'm a partner at Object Computing, and I'm also the 2GM team manager. We call our 2GM practice, 2GM is short for Groovy, Grails, and Micronaut, 2 Gs and an M. Today I'm going to talk about the history of how Object Computing, or OCI, and Micronaut started collaborating with JHipster on the Micronaut blueprint for JHipster, and the benefits that we realized from that relationship. So you're probably already familiar with JHipster, but you may not be familiar with OCI. So let me introduce us for just a moment. We are a IT solutions organization. We have practices on all sorts of things: AI and ML, blockchain, Internet of Things, and industrial Internet of Things, cloud. We work with clients in a whole lot of ways to support, enhance, and grow their business. So that includes consulting, training, solution development, cloud migrations, assessments, technology assessments, basically anything that's in that IT solution space. We do. We also provide training and support for our open source products. So open source is a part of our DNA at OCI. We've been writing and maintaining open source products since our founding in 1993. We have over 20, including the four logos I've displayed here. If you're in the JVM space, and I presume that you are, you're probably familiar with, or you've at least heard of, Grails and Micronaut on the left here. OpenDDS and ACE and DAO are more in the C++ middleware space. So if that's someplace that you're not, you may not be familiar with those. But we do a lot of open source development. It's something that we really believe in. And I'm presenting today specifically about OCI and Micronaut. So let me just introduce you to Micronaut real quick in the event that you're not familiar with us. So Micronaut is a JVM application framework that was built for fast startup time, fast throughput, and low memory. Basically, we want to make it optimal to create applications that can run in resource-constrained environments or in environments where resources cost money, right? So cloud environments. Right. Also, this is beneficial in the IoT space and other places as well. So it started off as an initiative to speed up and improve Grails applications, right? So that's kind of where all of this started. If you're familiar with Grails, you know that they kind of, many Grails applications resemble the monolith type applications that you would build in JHipster. That's not necessarily true. You can certainly build microservices with Grails, and some people do. But a lot of people, they'll put everything kind of in a Grails project. And we wanted to realize some of these benefits of faster startup times, lower memory footprint, and the like in Grails. And that was successful, really. The Grails 4, which is the latest major release of Grails, has Micronaut as its parent context. We include native support for multiple cloud environments. And while we're focused on microservices and cloud and those sorts of things, at its core, Micronaut is about a dependency injection and aspect-oriented programming without reflection, right? Using ahead-of-time compilation strategies. So you can really create any kind of application with Micronaut. If you go out to the Micronaut launch, there's an application type in there to build a CLI, for example. So beyond Java, we include support for Groovy and Kotlin, and some work has started for Scala as well, which is exciting. And we also have an excellent relationship with the GraalVM team. Just as a quick example, so we built a pretty thorough CI pipeline to exercise GraalVM. And what it does is it'll test the latest GraalVM builds against multiple Micronaut applications and configurations to make sure that they still work. And in the past, we've found bugs in GraalVM before they release. They've fixed them and then used our CI to validate that the bugs have been fixed. So if you're into the GraalVM space, we have really top-notch support there. Lastly, before I get into our relationship with JHipster, earlier this year, we announced the creation of the Micronaut Foundation. The Micronaut Foundation is a not-for-profit entity dedicated to leading the Micronaut framework. So we've established a technology advisory board that meets and discusses and guides the future roadmap of features for Micronaut. What this really did, so we had the ear of a lot of industry leaders when we were working on Micronaut. This really formalizes that process, and it opens doors for a collaboration, right? So it lets us interact with a lot more folks within the industry and get formal feedback, so that we're not we want to make sure that we steward Micronaut well, and that we guide it in the right direction, and that's what the Micronaut Foundation is helping us do. And just yesterday, we announced sponsorship levels for the Micronaut Foundation. So if you or your company would like to donate some money to help Micronaut continue to do the great work it's doing now, please visit our website and check that out. Okay, so let's talk about Micronauts and the Micronaut JHipster blueprint. So what I'm going to do is just talk through kind of a brief timeline of how the blueprint got to where it was, and it starts with JHipster, right? So Sendil here on the left created the initial repository and started a conversation right out in the open in the issues about what sort of features it should support starting out. Frederick here on the right contributed to that. So this is before we were even involved with the blueprint at all. And I want to take a moment here to give a hat tip to Frederick. So he's been involved with this effort since practically day one. He's still very active. The framework, the blueprint would not be as far along as it is if it wasn't for Frederick's contributions. So JHipster's open source, Micronaut's open source, OCI is a strong advocate of open source technology. It made a lot of sense for us to start contributing here. And just kind of a short list of benefits that we were going to get from it is JHipster has a large JVM user community that we can introduced Micronaut 2 this way. It gives us an opportunity to generate new Micronaut applications, complete with domain classes or entities in the UIs. And at the time, we were looking for a mechanism to compare Micronaut's performance against Spring Boot in a very level playing field. And JHipster seemed like a good avenue for that. We could create essentially the same application in 2 frameworks and then run them through the ropes and see how they compare performance-wise. So the first thing we did, and this is before my involvement, was we took the JHipster sample application and just manually converted it over to use Micronaut. Right. So once that was done, we had a goal. Right. So we said, okay, we want to be able to, using the blueprint, generate this application that we just manually created with the JHipster sample app. And that's where these 2 gentlemen came in here. So Will Buck and Zachary Klein both work for OCI, and they're both on the 2GM team. Will, in particular, on the left, did a lot of the heavy lifting early on to get the blueprint to generate the sample application. The first successful generation of the monolith project type was done under his watch. So a challenge that we hit early on was the management endpoints differ between Micronaut and Spring Boot. And so the UIs had to be altered in order to consume the management endpoints that Micronaut provides. So unfortunately, we were hoping to get away with not working on the UIs as well and just providing a different backend. But to date, we've not been able to realize that dream. Zachary Klein here came in a bit after that and added support for some additional databases. He worked on some of the OAuth things that Matt was talking about earlier, and moved us forward as far as feature sets go. All right, so once we got things in a pretty good place and we started publishing early versions of the Blueprint NPM, we started getting some additional contributors, which was great. Matt just spoke about the blog post he put together about the Micronaut blueprint with Okta and Heroku. And he designed a space application that really helped us work out some of the bugs for apps that didn't match the sample app. So it had different entity types. It had like enums in it and things that we weren't doing in the sample app. And it kind of helped us find a lot of those bugs. And I want to take a moment here to recognize Agloby and Murdos here. So they both have, they've both contributed to the blueprint multiple times. The blueprint's in a better place because of their efforts, and they both have work in progress PRs right now. So Agloby is working on GraalVM support, and Murdos is working on dynamic queries, which is really cool because Micronaut Data is working on dynamic queries at the moment. So he may beat us to that, which would be very interesting. So, and another thing that helped us at this stage was Matt Raible went out and put some bug bounties on some of the issues in the repo and got us some more attention that way. And between you and I, there's still a couple of unclaimed bounties out there. So if that's something you're into, you might want to go check us out. So here's kind of a short list of the features that we support right now. So we don't support everything that the upstream repo does yet, but we're working on it. Monolith projects, microservice projects, Murdos contributed a lot to that. JWT and OAuth 2, SQL databases, a couple of cache implementations. You can use Maven and Gradle. You can have an Angular React UI or no UI. Protractor tests and Heroku, which Frederick contributed a lot to. All right, so let me take a moment here and demo, and I'm hoping that I didn't share my whole screen, did I? I just shared the slides. So let me stop, and I'm going to reshare. I'll just share the whole screen, I think. So I'm hoping the demo bugs don't bite me here. All right. So first thing I want to do, let me check really quick here, and yeah, looks like you guys can see my screen. First thing I want to do is just run the mhipster command. right? So just like JHipster, you can run MHipster, short for, of course, Micronaut Hipster. It is taking a second to start up here, but any moment now it should pop right through that. Here we go. Some more info. And we've recently updated MHipster to support the latest Micronaut, which is 2.2.0. So this represents kind of the latest of what's available. And I'll walk through some of the options here. So like I said, monolith or microservice, name and a base app. I'll pick JWT. I'll say we'll do it all with Postgres. Use caffeine cache. Sure. Gradle. Client. Okay, and there's more options that we didn't see here, but it does the same thing that the upstream JHipster will do, right? Except it's using the Micronaut blueprint, right? So it's overriding a number of things specific to Micronaut, including most, if not all, of the Java, the server-side classes. So another thing we support here in if you do make it out to the repo and you look at our CI in using GitHub Actions, we use JDLs to verify that anything we're changing doesn't break the way that MHipster behaves. So we support the import JDL. I just learned about the JDL command from Matt here a moment ago. I'm not sure if that would work with us. But I'm happy to try it here. This JDL, by the way, represents the application that Matt created for his blog post. It's this space application, and it found so many bugs for us that we incorporated it as part of our CI. I'm not going to go through the npm install. I do have a pre-baked app here ready. It's that same app. So if I show you the JDL real quick, so we're looking at OAuth 2. Our database is in here somewhere. Postgres, I believe. Yes, there it is. So here's the settings that we're using here. I've got that generated already over here, just so I can kind of show it running. I've pre-built it. I also have so I've got the Keycloak container and the Postgres container already running. Here we are. And I will just create a new, not 5,000. All right, so this should look a whole lot like the JHipster UIs that you know and love. Harper, which is the name of our hipster here. You can see she's got a Micronaut t-shirt, and then that's a teeny tiny Sally astronaut on the mug there. If I go to sign in, it's going to redirect me to Keycloak. I'll log in here. We can change the language. We've got the metrics endpoints here. The health checks, something isn't functioning with the translation here. I'm going to need to look into that. But the health checks area and configuration options, right? So all those are available. Here's the entities. So we have missions. This is all the randomly generated stuff that happens with the database creation. But I can create a new one. Right. So all the CRUD operations that we know and love are available here. And let's see, space event. I went ahead and added this in earlier, so it links back to mission and all of that. So there we go. Let me go back to the slides. All right. So here's some resources for you. So the repository is by far the best way to take a look around and see what we're doing and see how maybe you can help. Here's just yet another link to Matt's blog post here for building a secure Micronaut and Angular app with JHipster. And then I talked about that performance comparison that we did early on. This is a blog post that walks through that. Basically, what we did was we used the Spring Boot sample application and then generated a Micronaut sample application that's the same, right, to compare it with, and then did things like measured the startup time, the throughput. So if you want to check that out and look at the results we got, please do. If you're interested in learning more about Micronaut itself, and I really hope you are, here's some places to start. If you haven't made a Micronaut application before, I suggest visiting this Learn link first, the third one down, and starting there. Right, the foundation site, which we talked about before, is the fifth one down there. And of course, you can navigate to all those from the base site. And as I mentioned earlier, object computing, one of the ways we create revenue is to provide commercial support, training, and consulting for our open source products, and that includes Micronaut, Groovy, and Grails. So if you're working in a Micronaut or Grails shop, or if you're interested in introducing Micronaut or Grails to your team, please reach out to us. So we're always interested in how you are using our products and our technologies. So even if you don't need any help with anything, we always want to hear about what you're doing. And then, and if you do want some help with something, I think you'd be hard pressed to find a group that'd be more qualified to help you with Micronaut or Grails than OCI. So this is my contact information if you want to reach out to me personally. And thank you so much. Let me stop sharing here.
Thanks a lot, Jason.
You're mute. Oh,
yes.
Okay.
Thanks, Anthony. Thanks a lot for the presentation. It looks like we don't have any questions from the chat right now. But if you have some closing remarks or just want to chat for a couple of minutes with Matt and Anthony, just leave it to you.
Yeah, so I would have a question for you, Jason. I noticed that you had the monolith support and the microservice support. Is there anything in Micronaut for the front-end gateway in a microservices environment?
So yes, although there's nothing in the blueprint to support that. So what we're trying to do is, so far at least with the blueprint, is use the gateway that would be provided by JHipster. Okay.
And then what about reactive support? Is that, so both of those, I believe, reactive and a gateway are things that Micronaut provides, right? It just hasn't gone into the blueprint yet.
Yeah. So you can do both of those things with Micronaut. We have a lot of reactive stuff. We've just, in the latest release, added a preview of R2DBC support in Micronaut data. That's getting, it's continuing to be fleshed out with this next release here, but we've always supported reactive types in the framework. If not from day one, then from day 1.5, pretty early on.
All right, so it sounds like we need some new issues that I can put bug bounties on, right, to get some community members.
We have one for reactive, and I think you put a bounty on it.
Okay. Yeah, I'm excited about that.
Yeah,
because we have it in the regular one, and it's like for me, it's just a neat new paradigm, right? Because it's not as easy as the regular Java code we've been writing. Like it's a whole new way of writing code because you're trying to stream stuff and not block and everything. So it's been a great learning experience.
Yeah, but the benefits are huge.
So yeah. you have received both a lot of thanks from the chat. I mean, for example, from Frederick.
There's Frederick. He's our hero.
He is.
Yeah. From Matthew, who is from the developer JHipster team. And we do have a question from Frederick. the work on reactive planned after the 1.0 blueprint?
I think that's a statement.
That's a statement.
Yeah,
Okay.
it's not a question.
Okay. Oh, yes, because Frederick is from the Micronaut team, blueprint team.
Mm-hmm. Yep. Yeah, he's contributed quite a bit there.
Yeah. Yeah, I have a question. How went the collaboration between different people that don't know each other, don't even come from the same company? How is the collaboration going between your company and the other contributors?
So we've been doing open source collaboration for a while. So I don't know. It's hard for me to judge what it would be like to not be doing that. So it's pretty effortless, right? We go into GitHub, talk via issues. Yeah, the collaboration's been great. The JHipster community has been great. I like the excitement that people bring to the table, about getting the blueprint to work, and it's nice to see Micronaut applications being generated and created in this way.
Well, what I really love about the JHipster team is in the US, right? You can work on it until, let's say, bedtime, and then you can put an issue out there, and by the time you wake up, the folks in Europe have woken up and fixed it. So it works out well.
Yeah,
never sleeps. I would have another question about the benchmark that you've done, which I think it's really, really interesting, especially now we have more and more options. I did do a presentation on the front-end benchmark, comparing React, Vue, and Angular. I would need to update this, but the comparison you did on the back end, what was the methodology or the way you did it?
So we measure different things different ways, and it needs to be refreshed, honestly. So at the time, we were just about to release Micronaut 2. And Micronaut 2 had a host of performance improvements as part of it. So what we were really doing was comparing Spring Boot, Micronaut 1, and then Micronaut 2, right? And showing the improvements across all three of those. So methodology-wise, we used Gatling for throughput. So it wasn't the Gatling that's generated by JHipster. We just set up a small project of our own. And it was doing CRUD operations, so it was creating things and then reading them, and that way, that's how we got kind of average requests per second, those sorts of things. And then we used just a little startup script to run time and see how long it took the applications to start, right? And we would, I think, run it. I'd have to look to be sure, but I think we ran it 5 times. And then we would take the best. So we would run each one 5 times and then take the best, because you know how it is, right? You'll run them twice in a row and you'll get vastly different numbers. So you want to kind of give everyone a fair shake there.
Yeah, I think JHipster could be a very interesting project to collaborate on benchmark, because often benchmark, people would accuse a company to use benchmark to promote their own. And with JHipster, I think we can work together and do something that is unbiased. Yeah.
Absolutely, yeah, that'd be great. That's precisely the kind of thing we were trying to avoid. It's easy to create this thing and then put all the cards in your favor and just feel like, oh, look how great we are. I will say that we got an issue not long after we wrote that blog post from someone pointing out that there were a few things that were different between the two configurations that made it a little less fair to Spring Boot. Like Spring Boot was outputting more logs and that kind of stuff. And so we did go in and post and fix those things, reran everything, and then we updated the blog post to be as fair as we could.
Yeah, that's really good of you. I mean, I've seen that you've published the source. I did not have the time to run it myself, so I think people can test the result independently. That's a really good process, I think.
Yeah. The source code's out there. It's available. You can look at it and scrutinize.
Well, thanks a lot. So we arrived at 7 p.m. here in France. So that's the end of our meetup. Thanks again. Thanks a lot, Matt. Thanks a lot, Jason.
Thank you.
And see you soon.
All right. Yeah. Bye. Thanks a lot.
Goodbye.
Bye.